All right, guys. So wanted to go over state function again because we did this with enthalpy, but it drives people a little bit batty sometimes. So I'm showing a reaction profile, and I'm not labeling it for energy or disorder or Gibbs free energy or anything like that. Okay. All it means is we're just showing you profile of, and it could mean for any of them. So I'm doing the black line, which shows up really well, and my red line, which is a little bit dimmer, but it's there, okay? So the first one is just a big reaction curve, and it goes down, and you've seen it a million times. And the second one is one that goes up a little bit, and then down, and then comes back up, and it ends at the same point. So a state function means is all that matters is where you start and where you end. It's the final net change. Your path doesn't matter. It's just where you start and where you end. So with both of these, the black curve and the red curve have the same starting point. They have the same end point. They have the same net change. So if you did their calculation, they would have the same energy change. They would have the same disorder. They would have the same delta G. She's here. They would have the same number, okay? Enthalpy, delta H, entropy, delta S, Gibbs free energy, delta G, are all state functions. They are path independent, okay? They all work like this. I could have done one that took up both erase boards and took home from school and done like 15 up and downs like a roller coaster. It starts here and it ends here, done, okay? I want to show something else here for a second. You're doing your calculations, and we're running numbers. There are two ways to find delta H. If you remember, you can either do it by bonds broken minus bonds formed. This is delta H for a reaction, okay? If you do it this way, it's reactants minus products, okay? It's one way to do it. You can also do delta H reaction. The delta H with your heat of formation of all of your products for each one of the compounds minus the delta H heat of formation for all of your reactants. They're flipped, and you've got to know which one you're dealing with. And you're always going to be given this information in a data table. If you're given a bunch of delta H values of individual compounds, you're going to need to do this way. And remember, it's going to be products minus reactants. And remember, sometimes you're going to be doing a negative minus a negative, which is going to be doing addition, versus here, it's always going to be a positive number minus a positive number, because these are bond energies that you're dealing with. Okay, so you've got to be able to keep that straight. Also remember here, the heat of formation for things that are elemental, like O2, F2, H2, these are going to have delta H of formations that are equal to 0. Things that are elemental, or like if you are given carbon, they're going to be 0 because they're elemental. They exist. We don't really have a way to measure them. So if you feel like you're missing a piece of information, it's like, I've got a reaction, but I'm missing the value for O2. I'm missing the value for oxygen. You're not missing anything. You're just forgetting something. Okay. So remember that. One way, so For delta S for a reaction, it's going to be like your delta H. It's going to be the delta S for all of your products minus the delta S for all of your reactants. And the same thing for your delta G. They could give you a table that's going to be the delta G for all of your products minus the delta G for all of your reactants. So they could ask you for any of this. Just accept it and deal with it, okay? So you could be asked for a value for your reaction of what's the delta S of this product. They could ask you for what's the delta H of this process. And then they could ask you for what's the delta G of this process. Or they might ask you for the delta G another way. And I'm going to get into that in just a second, and then I'm going to work an example or two for you out of your problem set, and then I will shut up so you've got enough stuff to review. KK? KK. Jalapeno says she loves you.